Hi, my name's Luke. In this video, I'm going to be going through Maths Higher Level Paper 1, Section A from 2021. Along the way, I'm going to be referencing the marking scheme, and as well as that, I'll be using the formula book. Okay, so let's start. Okay, so question 1 is a question on complex numbers. And when we do questions on complex numbers, they're mainly just algebra questions with a little bit of a difference. And the main difference is that we have this I squared is equal to -1, so that will always come in. Another difference is when we're dividing by a complex number, we have to approach it a little bit differently. Now, if I said a complex number z was equal to 2 plus 4i, then its conjugate, well, it's another complex number, but what we do is we take this sign in the middle and we change it and we make it a minus sign, okay? And what we're going to do, and this is the special way that we do division of complex numbers, is we take that same complex number and we multiply it top and bottom by a fraction. Now you can always do this because if you multiply something over itself is always 1, and you can always multiply a fraction by 1 and not change it. And that thing that we multiply top and bottom is the conjugate of this z here, okay? Now, why do we do that? The reason is that we don't really like to divide by a sum of things, right? Because, you know, we can have a sum of things on the top of a fraction and we could divide like so or something like that. But if we have a sum of things on the bottom of a fraction, our division won't work. So what we want to do is we want to make this two things into one thing so we can divide it in. Now, how do we do that? It turns out if you multiply a complex number by its conjugate, it turns into just one thing. So we'll just multiply out the top line. So it's going to be 4 times 2, 4 times 4i, and then minus 2 times 2 and minus 2 times 4i. So that gives me 8, and then minus 16i, and then minus 4i, and then minus 2 by minus 4 will be plus 8, and then I squared. And then the bottom line, we're going to be 2 by 2, 2 by minus 4i, 4i by 2, and 4i by minus 4i. So that's going to be 2 by 2 will be 4, 2 by minus 4i will be equal to minus 8i, 4i by 2 will be plus 8i, and then 4i will be minus 16i squared. And what we see is that these cross terms, so that's the cross term, I mean this by this one and this by this one, they cancel, okay? And what we're left with here is, on the top line, 8 minus 20i, and then instead of plus 8i squared, it will be minus 8, because the I squared will put in minus 1, and then we'll get minus 8. And on the bottom line, we have 4, and then this minus 16i squared, well, that's going to be minus 16 by minus 1, so it's going to be minus 16. Minus 16 by minus 1 will be plus 16. And so on the top line, we end up, they cancel off, and we have minus 20i over 20. So you see, this is what I mean. Now we are dividing by one thing, instead of dividing, initially we're dividing by two things, and then we can divide that in and we get minus I, which is the same as 0 minus I. Now the original question was up here, was 0 plus ki, so that would mean that k would have to be equal to minus 1. Okay, so for the next question, we have to work out the square root of a complex number, minus 5 plus 12i. Now, if we take, the square root of a normal number, we mean, what number when multiplied by itself will give us this number that's inside the square root. And in this case, it could be 2, but it could also be minus 2. So we'd say plus or minus 2. Now, what we're going to do here is we're going to say that the square root of minus 5 plus 12i, this is equal to some complex number a plus bi, right? So we want to find out, what complex number ends up being the square root of minus 5 plus 4i, in the same way as we're saying what number ends up being the square root of 4, okay? Now, in order to find this, what I'm going to do now is I'm going to square both sides. So I can now square both sides, okay? And on the left-hand side here, I get minus 5 plus 12i. And then on the right-hand side, I've got a plus bi multiplied by a plus bi, which is equal to, well, a squared plus 2abi plus b squared I squared, which is the same as a squared And then this b squared I squared, well, the I squared becomes minus 1, so this becomes minus b squared, and then it's 2ab times I. Okay, so when we write down complex numbers, we always write the first part without any i's in it, and we group them all together and we say that they're the real part. And then we take the second part, this 2ab, and this is the piece with the I in it, and then this is the imaginary part. And now what we can do is we can say, well, in the original complex number, the real part was minus 5. So that means that minus 5 is equal to a squared minus b squared. And then 12 is equal to 2ab. And this is a simultaneous equation. Okay, so now we have to work on this. So the first one, well, we can cancel off a 2 here. We've got 6 is equal to ab. And this tells us that b is equal to 6 over a. So now we can go back to this one here, and we've got minus 5 is equal to a squared minus b squared, which is minus 6 over a all squared, which is a squared minus 36 over a squared. And then you multiply across, so that's minus 5a squared is equal to a to the power of 4 minus 36. And this tells us, well, if we bring everything to the one side, that a to the power of 4 plus 5a squared minus 36 is equal to 0. Now, if we take this to a new page and just work at this, what we have is we have a quadratic, well, it's to the power of 4, but it's a quadratic in a squared. So we can separate a squared, and then two numbers that multiply to give 36, that add to give, that multiply to give minus 36, and that add to give plus 5. Now our possibilities could be like 1 and 36, 2 and 18, 4 and 9, or 6 and 6. So these are the numbers that multiply to give us 36. And if we look at this, the only possible combination that can give us a 5 is the 4 and 9. So this is going to be 4 and 9. And what we need to be minus. So we need one of these to be plus and the other one to be minus. And then, but we need them to add to be plus 5. So I'm going to say this plus 9 and this minus 4 is equal to 0. And then this will be, well, either a squared minus 4 is equal to 0, or a squared plus 9 is equal to 0. This first one gives us that a squared is equal to 4. Is equal to, a squared is equal to 4, or a squared is equal to minus 9. Now we're going to disregard that one because we need a to be a real number. And this gives us that a is equal to plus or minus 2. Now remember from before that b was equal to 6 over a. b is equal to 6 over a. So that means that, well, if a is equal to 2, then b is equal to 6 over 2 is equal to 3. Or if a is equal to minus 2, then b is equal to minus 3. So we have our complex number 2 plus 3i, or minus 2 minus 3i. So these are the two complex numbers that if you were to take the square root, so if you were to square this complex number, you would get minus 5 plus 12i. Or if you were to square this complex number, you would get minus 5 plus 12i. Now we could have answered the previous question by using De Moivre's theorem. So De Moivre's theorem is here. And what happens in De Moivre's theorem is that you initially express the complex number in polar form, and then you have this power that's on the outside, and then you're going to drop that number in. So for us, the last time, what we could have done is express this minus 5 plus 12i in polar form, and then taken this n to be equal to a half, and then drop that in. But the method that we used was faster to do that, so that's why we went for that. But this time here, we won't have that option, and so it's going to be better to use De Moivre's theorem. So what I'm going to do is I'm going to say z, first of all. We don't know what it is, but we called it a plus bi. And z cubed is equal to minus 8. Now, because this is a question about complex numbers, why don't I just add on a 0i? You know, it's not wrong. It just writes down minus 8 as like a complex number with this I part in it, okay? So now z cubed is equal to a plus bi cubed. This is equal to minus 8 plus 0i. And then if we take the cubed root of both sides, we have a plus bi is equal to minus 8 plus 0i to the power of 1 over 3. Now, so this is the thing that we have to work out here. Okay, so now what we're going to do is we are going to take minus 8 plus 0i. Now this is a complex number that's given to us in Cartesian form. So what does that mean? That means that it has an x part and a y part. And we're going to convert that into a complex number that's written in polar form, which would be or cos theta plus I sine theta. Okay, so let me show you that on a diagram. So minus 8 plus 0i, this is minus 8 here, and then 0i, so this here. So if we take the, the x part of this, the real part of this here, and we take the imaginary part of this complex number, we can make a point, which is this point here, minus 8, 0, okay? And what we can do, so this is in Cartesian form. Now another way to get a point in an xy diagram like this is to not just think about the xy coordinate, but to think about the distance that the point is away from 0, and then the angle here. So that's this distance here is or, and this angle here is theta. Now, often when you do these questions, you have a triangle and you have to work out the angle inside the triangle and so on. But for us here, we can actually just see straight away from the diagram that the radius of this thing here has to be equal to 8 because it's just going out to that point there. So or is equal to 8, and then it's also clear that theta is equal to 180 degrees. Okay. So now we can write down this polar form here as or, which is 8 times cos of 180 plus I sine of 180 degrees. Now if you put this into your calculator, you're just going to get minus 8 plus 0i. Okay, so why are we doing this? Well, what I want to do is I want to take minus 8 plus 0i and I want to put it to the power of a third. And that's the same as taking 8 cos 180 plus I sine 180 and taking all of that and putting it to the power of 1/3. Now, if you've got a, b all to the power of n, because they're multiplied, you can take each of these things separately and put them to the power of n. This is one of our laws for indices. So if we're taking this whole thing to the power of a third, that means that we can, take a to the power of a third, take them separately like this. Now, first of all, a to the power of a third is 2. And then cos of 180 plus I sine 180 all to the power of a third. This is the thing that we have to work out. And this is what we're going to use De Moivre's theorem here for. So let me just drop that in. So here it is. Now the temptation would just be to take that n and then to just play. We could just, the temptation is to take this 1/3 and just put it in here and put it in here. But if we do that, we're going to be, well, we're not going to be wrong. We're not going to get the full answer. We're only going to get a part of the answer. So the trick is when this power, okay, so when this n here, when it's less than 1, we have to modify this slightly. So let me write that below. So this is equal to 2, and then cos 180, and I'm going to put that in brackets and leave a gap there. Sine 180, and I'm going to put that in brackets and leave a gap there. And what we're going to do here is we're going to add in 360. This is the modification that we're going to do to the complex number. Now these two things are equal to each other, okay? Why are they equal? Because if you take an angle, let's say this is an angle theta, okay? And we think about what does adding 360n mean to this? Well, let's take n is equal to 0 first of all. Sorry, n is equal to 1 first of all. What that means is if you take theta plus 360, that means, there's your angle theta, and then do a full turn and you get back to the same spot again. And then if we took n is equal to 2, we'd be adding on 720. So that would be like, theta, and then do 2 full turns, and then you get back to the same spot again. So that's why we're allowed to add on 360 times n. Okay, so what do we do? So this is still to the power of a third. We're going to set n is equal to 0, n is equal to 1, and n is equal to 2. Now because of this, this 3 here, we get 1, 2, 3 different answers. You can go on and get a fourth, but it's going to turn out that fourth is going to be the same as the first. So you'll just waste a little bit of time, but it doesn't matter. So the first case it's going to be 2 and then cos of 180, and then now n is equal to 0, so that's gone, right? So just cos of 180 plus I sine of 180, and this is to the power of 1/3, okay? So that's going to be 2, and we use De Moivre's theorem. So what does De Moivre's theorem say? It says takes the n and put the n multiplying in front of the angle. So this is going to be 2 cos, and then it's going to be 1/3 multiplied by 180 plus I sine, and then 1/3 multiplied by that 180, okay? So this gives us 2, and then cos of 60 plus I sine of 60. And then if we go over to get these cos of 60 is equal to 1/2, and sine of 60 is equal to √3/2. So this is 2 times 1/2 plus √3/2 times I, and then the 2's cancel, and we have 1 plus √3I. So that's our first answer. Okay, so then for the next case, n is equal to 1, we've got 2 cos, and it's going to be this time 180 plus 360, right? Plus I sine of 180 plus 360, all to the power of 1/3, which will be 2 cos of 540 plus I sine of 540 to the power of 1/3. And now what happens there is that we get this is going to be 2 cos. Now, we can now apply De Moivre's theorem directly. So we take that n, which is 1/3, and we can now drop it in place of the angle there. So it becomes 2 cos the 540 plus I sine the 540. And then we can just drop in that 1/3, like so. And then 540 divided by 3 is 180. So this becomes 2 cos of 180 plus I sine of 180, which is equal to 2 times minus 1 plus 0I, which ends up being equal to minus 2. Which makes a lot of sense, right? Because the original question was, you know, what cubed will give you minus 8? Well, if we would take minus 2 cubed, it'll give us minus 8. So if z was a real number, the answer would be easy. It would just be minus 2. So that's this bit here, okay? And then the last piece is when n is equal to 2. So this time we have 2, and then cos 180, but then 2, this will be plus 720. So cos of 180 plus 720 will be 900 plus I sine 900, all to the power of 1/3. And then we take the 1/3 in, and we get 2 cos of 300 plus I sine of 300. And then when we work that out in the calculator, we get, well, 1 minus √3I is what we get for that one, okay? Okay, so our three answers for z is equal to 1 plus √3I minus 2 and 1 minus √3I. So if we take this number, we multiply it by itself 3 times, we'll get minus 8. If we take this number, we multiply it by itself 3 times, we get minus 8. And finally, if we take that number, multiply it by itself 3 times, we get minus 8. Okay, so just want to look at the marking scheme then for question 1. So you can see the high partial credit here is 7 out of 10. And you get the high partial credit for doing this step here in the first line. So if you don't work out anything else below that, if you just realize that you have to multiply top and bottom by the complex conjugate, then you're going to get 7 marks out of 10. So that's good to know. Here, the high partial credit is 8 out of 10. And you're going to get 8 out of 10 if you find one of these, right? Or if you find the second one, or if you get that, if you just don't get the plus or minus part, if you just get one of them, it seems that you will get the high partial credit. And then there's obviously another way to do that question there, but I'll leave that to you to look at. And then here, the high partial credit is 8. And we get the high partial credit if we get one of the roots evaluated. So if we didn't put in this 2n pi piece here, or this 360 times n piece, then we would have just gotten the first answer, and that would still have given us the high partial credit. So question 2. There's a couple of ways of doing question 2. What I would sort of recommend, if there's a simple way of doing a question with common sense, you can always just do it that way there, okay? So we realize that if we have the absolute value of something, like if we take the absolute value of -4, what we're doing is we're just sort of we're neglecting the minus bit of it, right? We're just taking the positive value. So the absolute value of 4 then is also 4, okay? So the absolute value just gets rid of the sign, okay? So if we have the absolute value of x plus p, right? If this was a 5 inside, then the absolute value of 5 would give us 5. So the question is, how do we get a 5 in there, right, if x is equal to -3? So we'll rewrite that. X is -3, -3 plus p. Okay, so how do we get a 5 in there? Well, if p is equal to 8, then that would be -3 plus 8 would give us the 5. That's p is equal to 8. But likewise, or sorry, in the other way, the absolute value of -5 is equal to 5. So that would be so then the question is how do we get -5 to be in there? So -3 plus p. So here, if that p is equal to -2, then we would have -3 minus 2 is equal to the absolute value of -5 is equal to 5. Okay, so the two answers are p is equal to 8 and p is equal to -2. Now, another way to do this question would be to, let's sub in the -3 plus p and the absolute value is equal to 5. And what we could do is we could square both sides, because as soon as you square both sides, you lose these absolute value signs. Because if you think about it, the absolute value makes things positive, but also squaring things makes things positive as well. So you can lose those absolute value signs when you square. So that would be p squared minus 6p plus 9 is equal to 25, and then we bring this across. So p squared minus 6p minus 16 is equal to 0, and then if we take brackets, p and p, okay, two numbers that multiply to give -16 and add to give -6. It's going to be 8 and 2, with the 8 being minus and the 2 being plus, equal to 0, and this gives us p is equal to -2 and p is equal to 8 as our two answers if we do it that way. The next question, x plus 4 is a factor of x cubed plus qx squared minus 22x plus 56. So we're told it's a factor of this thing here, so that means it divides in evenly. And it says show that q is equal to -5 and then find the other three roots. Well, the first thing to realize, if x plus 4 is a factor, then that means, basically, we'll have this x plus 4 is equal to 0, and then x is equal to -4. It's another way of telling you, if they tell you that x plus 4 is a factor, then it's x is equal to -4 is a root. And what we're going to do is we're going to sub in that -4, and we know that will give us 0. So the progression is that x plus 4 is a factor, -4 is a root, and then if we sub in -4 into f of x, then we get 0. Okay, so what happens when we sub it in? So that tells us that -4 cubed plus q times -4 squared minus 22 times -4 plus 56 is equal to 0. So we have, well, -4 cubed will be -64 plus 16q, and then plus 88, and then plus 56. So let me just take the 56 with the 64 first of all. They'll cancel and give me a -8. So I'll have -8 plus 16q plus 88, and then the 8 will cancel with this one here. So that'll be 16q plus 80 equal to 0. And then I'll have 16q is equal to -80, and divide across, and q is equal to -5. Okay, so that was the first part to show that q is equal to -5. Okay, so the next part is to find the three roots of f of x. How do we do that? Well, we're going to take we're going to take x plus 4 and we're going to divide it into x cubed. Now we found q is equal to minus 5, so I'm going to sub that in. Minus 5x squared minus 22x plus 56. Okay, so the first step is we put a number here that multiplies by the x so that here we get an x cubed. Okay, what does that be? Well, that has to be x squared. So we multiply the x squared by the x, we get an x cubed. Then we multiply the x squared by a 4 and we get plus 4x squared. And I'm going to draw a line like this. Okay, next step, we have to change the signs of these two. So we change the signs. Now these cancel and we end up with minus 9x squared, and then we take these other two down. Okay. Okay, so that's the first stage. The next level, okay, we have to put a number here that multiplies by the x to give us a minus 9x squared there. Okay, what's that going to be? It's going to have to be minus 9x. So minus 9x multiplies by the x to give us minus x squared. Then we have to multiply it by that 4 there. It gives us minus 36x. And then draw that line there, change the signs, and then we see that these cancel. And then this one here gives me 14x plus 56. Okay, last step. And just notice that like the way it goes in a step of stairs like this, okay? Last step, a number here that multiplies by the x to give me a 14x. Well, that has to be 14. So 14x, and then the 14 multiplies by 4 to give me a 56, and then when we change the signs, we see everything cancels, which is what we expect because x plus 4 is a factor, so it goes in evenly. Now, just in the same way as we could, like, for example, take the number 30, and we could say, well, 30 is 2 times 15, but then we could take the 15 and say 2 times 3 times 5. So we can take this thing here, this second factor, and we can split that second factor into 2 more factors. That's what we have to do to get the 3 roots of this thing here. Okay, so take this second factor, x by x here, and then a 2 and a 7, and then a minus and a minus. So minus 2 by minus 7 will be 14, and then minus 2 and minus 7 will be 9. So we have x minus 2 and x minus 7. So x plus 4 is one factor, x minus 2 is another factor, x minus 7 is another factor, and we set them all equal to 0 because what we're going to get, you see, is, you know, we have x plus 4 times x minus 2 times x minus 7 equal to 0, and that's only possible if this is true. That would be a 0 here, which would multiply by everything else to give us 0, or if this is true, which that would be the 0, or if this is true here, right, then that would be the 0 multiplied by everything else to give you a 0, okay? And the first one tells us x is equal to minus 4, the second one x is equal to 2, x is equal to 7. So this is our answer here. These are the 3 roots. Okay, now just looking at the marking scheme for this one here, the high partial credit for question 2 part A is 8. And you get that if, well, first of all, if you got that quadratic and you factorize the quadratic, so if you got to that line there, or if you got like these 2 linear equations, so if you had like split it into an equation for the, not gotten all the way to the p is equal to 8 and not but gotten halfway there, then you would have gotten the high partial credit. And then for question 2 part B, there's a high partial credit of 15. And if you basically got this here, this second factor in quadratic form, and you got the a part, q is equal to minus 5, then in that case, so if you hadn't done the final bit to get the 2 and 7, you would have gotten the high partial credit as well. Is a mixture of a sort of a volume question and an algebra question. And, you know, they like to give these questions on the Leaving Cert where they're sort of mixing like algebra with, like mixing kind of 2 different topics together. And what's always going to help you when you do questions like this is to just go into your diagram and like put loads of like labels like in your diagram, okay? So like what we realize is that all of these faces here of this cuboid here, they're all like rectangles, okay? And we have this Z that appears, well, this is also Z here, right? And that's also Z here, okay? And this is Y here, so that's also Y up there, okay? And this is X here, so that's also X here, and that's also X over there. So what I'm going to do is I'm just going to go into my diagram, and I'm just going to Now I'm going to label up, there's an X there. Okay, there's a Z there. Here's a Y here, you know, there's an X. Just put like loads of labels onto my diagram. Now the next thing I do when I have questions like this is I'm going to, you know, separate out the sides. Okay, so this is the side which has got an area of 2 root 2, and it has, this is X and this one here is Z. And here's another side here, so that's like, you know, this face here, right? So that's going to be, you know, 8 root 6 is the area, and then this side here is Z and this side here is Y. And then the top one, and I'm going to put the top one in a kind of a like a standing on the end like this. So this side here is X, and this top one here, sorry, this top one here, I mean. So this is X, and then this side here is X, that side there, and then this side here is Y, that's that side there. And 4 root 3 is the area of that side there. So most of the time when you get these like complicated, like, you know, shapes with many different like 3D shapes and things like that, what you're going to do is you're going to sort of peel them, like take out 2D surfaces, you know, take out one side and separate them into different pieces like that, okay? And then what we have, you know, we always know that for like a rectangle, and this is the width, and this is the height, you know, then the area is going to be the height by the width, right? So the area of this first one, this is like the area of the first one, is equal to 2 root 2, and it's its height by its width, right? So it's X times Z. And the second one we'll call A2, so this is A1, A2, and A3. A2, that's going to be 8 root 6, and that's going to be equal to Z times Y. And then A3 is going to be equal to 4 root 3, right? And that's going to be X times Y. So what we can do now is we can take these three, right, multiply them all together. 2 root 2 by 8 root 6 by 4 root 3 is equal to xz by zy by xy. Now, why are we going to do this? And the reason is that we're looking for the volume of the shape. And the volume of this shape here is going to be x times y times z. So we need x times y times z. And the way to get there is to find an expression with x, y, and z in it all multiplied, okay? Now if we look at this one here, well, we've got 2 times 8 times 4, which is 64, and then root 2 by root 6, so root 2 by root 3 is root 6, and then root 6 by root 6 will be times 6. And on the left-hand side, we have x squared, because we have an x with another x, we have a y with another y, and a z with another z. So x squared, y squared, z squared. And now we can get that x, y, z is equal to the square root of this side here, which is going to be 8 times root 6. And then they said they wanted in the form of centimeters cubed. So at the end, I'm just going to add on a centimeter cube. Anytime you write down an area or a volume or something like that, it's possible that they want the unit. In which case, you know, you just be careful to look back at the question and look at what they asked for, and then you can just add on that thing at the end. If you don't do that, you lose a mark, and it's not really a good reason to lose 1 mark out of 10. Okay, the next question. We're told that this f of x is equal to 3x squared plus 8x minus 35, and we want to find the 2 roots of f of x is equal to 0. Now, when we do this, we're either going to be able to factorize it using brackets, or we're going to have to use the quadratic formula. And when you have to use the quadratic formula, they almost always say like correct 2 decimal places, because the quadratic formula usually gives you sort of decimal answers, or answers that you have to round off. Now, the fact that they haven't said that suggests that probably this method will work, okay? So let's give it a go. You know, like, it's not too much lost, you know, to try a method. If it doesn't work, then try another method, as long as you're not spending too much time at it. Okay, so for the first number here, well, this 3x squared has to be 3x and x, okay? And then the second one here, well, 35 could be 1 and 35, or it could be 5 and 7, and there isn't anything else. So I'm going to try 5 and 7 first, okay? Now, if I'd made this one 7 and this one 5, then I'd have 21 and I would have 5, and there's no way to get 8 from 21 and 5. So let me try it the other way around, 5 and 7. So 3 times 5 will be 15, and then that'll be 7, and so that'll be like, yeah, 15 minus 7 will give us an 8. So if I say this is the plus and this is the minus, then I've got minus 7 by plus 5 will be minus 35, and then I'll have that, 15 minus 7 will be the plus 8, okay? And that's equal to 0, so this gives me x is equal to 7 over 3, or x is equal to minus 5. Okay, so that's that one answered there. Okay, so the next question, we're asked to solve this weird looking thing, 3 to the power of 2m plus 1 is equal to 35 minus 8 to the power of 3m. Now, I'll even say you don't really have a method to solve like an index equation like this, but what they've said here, they said the word hence or otherwise, but what that means is that we have to take our answer from the previous part and use it over here. So in the previous part, we had that 3x squared plus 8x minus 35 was equal to 0, and then that led to the answers x is equal to 7 over 3 and x is equal to minus 5, okay? And somehow we're going to have to use that here, okay? And this is a question that kind of comes up often. So what I have to do basically is take this side here, take this equation here, make it look like this equation here, and then we're going to do a substitution, and then it will become clear. So first steps to take this thing and make it look like this thing here. Well, here we have a 0 on the right-hand side and everything else is on the left-hand side. So let's do that first. So that means that we've got 3 to the power of 2m plus 1. So I'm trying to make this look like this, okay? So I'm going to bring over the 35. There's the minus 35. And I'm going to bring over the minus 8 to the times. This is 8 to the power of 3m minus 35 is equal to 0. And now we can see there's some kind of similarities. Like I have this plus 8 and that plus 8, and I have this minus 35. And instead of an x here, right, I have this thing here. So why don't I let x equal 3 to the power of m, you see, and then this would be plus 8 times x minus 35, you see, equal to 0. And then it would be the same as that with this substitution. But if I'm going to do that, I'm going to have to also change this around so that it looks like this 3x squared. Now it will get there, you just have to trust that it will get there because you wouldn't be able to answer the question otherwise, okay? So in order to get this thing to look like this thing here, I have to go over here to the tables and then just find the section on, here it is here. So we have to use our laws for indices here. So you've just got used to opening up this page and, okay, we're going to use this one and we're going to use this one here, and then it will become clear. So the first thing that we can do is we can take, you see this plus sign here, so we can say this 3 to the power 2m times 3. So let's do it over here. 3 to the power 2m plus 1 is equal to 3 to the power of 2m times 3 to the power 1, which is just the same as 3. And then 3 to the power of, this is 3 times 3 to the power of 2m, but 3 to the power of 2m is 3 to the power of m, all to the power of 2. This rule here, okay? So we 3 to the power of 2m, so we could take the 2 and put it outside like that. So that's over here. Then we have 3 times 3 to the power of m all squared. But remember, we said x was equal to 3 to the power of m, so this was equal to 3x squared. Okay, so it's a little bit of tricking around with indices to get there. So that means that now we already know that x is equal to 7 over 3, or x is equal to minus 5. So that means that we can say that 3 to the power of m, since x is equal to 3 to the power of n and equal to those things, we can say that 3 to the power of n is equal to 7 over 3, or 3 to the power of m is equal to minus 5. Okay, and now the question is, what's the question? The question is to get m. Okay, now this one we can disregard straight away because we can't, we can't take a number like 3. There's no power that will make it negative. Okay? You can't get a negative number by taking a plus number and putting it to some power. There's no special m that will get us there. Okay, no real number anyway. So then, so we only have to look at this one here, and now what we have to do is we have to you know, 3 to the power of m is equal to 7 over 3. We're going to have to get this m out of the index. So let me go to a new page for that. So 3 to the power of m is equal to 7 over 3. And if we go back and look at the tables again, this is a column here for indices, this is a column here for logs, and this is how we combine indices and logs. And this is the most important formula on this page is this one here. So let me just bring it across. Okay, now what does this formula here say? Okay, it looks a little complicated, but if you just look inside, you can see what happens. Here the x is a power, and on the other side the x is now down. And what's happened is we put a log here onto the other side, and it's a log. Now when you have log, you always need a base number, so it's log to the base of whatever x was a power of 4. Okay, so okay, so what we're going to do here is we're simply going to say m is equal to log of 7 over 3 to the base 3. Okay, now the question is, are we done now because we have m equal to something? And this is where they wanted our special form here, which is they wanted it written like this. See this log of p to the base 3 or something like that. So what does all that mean? All that means is we're going to have to go here and use one of the rules for logs. In particular, we're going to have to use this one here where we say log of something over something is log of that first thing minus log of the second thing. Okay, so this is log of the first thing to the base 3 minus log of the second thing to the base 3. And then if you ever have like log of a number and the base number is the same, this one ends up being equal to 1. And that's our answer there. So that's the form. So they said they wanted log of, see, they said they wanted to have log of p to the base 3 minus some q, where p and q were numbers. So that the p is 7 and the q is 1. So we're done. Okay, so looking at the marking scheme for question 3. Question 3a has a high partial credit of 8. And you get that if you get down to this expression here, right? So if you realize you multiply the 3 areas together to get x squared, y squared, z squared, you get the high partial credit. From 3b part 1, there's a high partial credit of 7. And basically, if you get to this line here where you factorize the thing, or if you were to sub in correctly into the quadratic formula, then you also get the high partial credit. And then from this part here, there's a high partial credit of 8. And you're going to get that high partial credit if you get down to this line here and you leave out the end. Okay. Okay, so question 4 is to prove by induction that this thing 2 to the power of 3n minus 1 plus 3 is divisible by 7. Now, when we do proof by induction, it's going to have always 3 steps, okay, to it. Now, every question on proof by induction, they're always different to each other, but these 3 steps are always done in every one, okay? So the first step is to show for a base case, okay? The second step is to assume for k, and the third step is to prove for k plus 1, okay? Now, the first thing to note is that these 2 steps here are always going to be easy and the same, and more or less the same in every example that you do. This is where the difference will come in. And we're also going to call this assumption here. We're going to call this the assumption, the induction hypothesis, and we're going to use this assumption in this part 3 somewhere. We're going to sub in the assumption in part 2 into it, okay? So let's get started. Showing for the base case, first of all, let's take n is equal to 1. And then this thing 2 to the power of 3n minus 1 plus 3 becomes 2 to the power of 3 times 1 minus 1 plus 3, which is 2 to the power of 3 minus 1 plus 3, which is 2 to the power of 2 plus 3, which is 7. And 7 is obviously divisible by 7. I do this vertical line to mean divisible. So that's the first part. The second part is we're going to assume for k, okay? That means that there is some k so that 3k minus 1 plus 3 is divisible by 7. Okay. Now, what's going to happen is, if this is true, this expression here changes for every single value of n. So we've got like a chain of n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. And this chain keeps on going on like this. Now, what we're going to say is somewhere in the chain, n is equal to k, it's true. And we're going to assume that it's true somewhere in the chain. Now what we have to do is we have to show that if it's true for this one, then it's true for this one. And what happens is I think about this as like, imagine if you had a line of dominoes. So what we show is two things in this proof here. We show that it's true in a base case, and then we show also with step 2 and step 3 that if it's true for the previous one, it's true for the next one. So the fact that this one is true will make this one true, will make this one true, will make this one true, right down the chain like a chain of dominoes, like so. Okay, so that's how proof by induction works. Okay. So we've done step 1 and 2. Step 1 was show a base case. Step 2, assume for k. And now step 3, what we want to show is that 2 to the power of 3, and it's not going to be k, it's going to be k plus 1, and we have to put it in brackets, minus 1 plus 3 is divisible by 7. Okay, so let's take that over onto the next page and work on that. So this was our assumption. And I'm going to write down our assumption over here. We're going to use that 3 to the power of k minus 1 plus 3, that this one is divisible by 7. Okay, so we're going to start here with this, and then we're going to get down to a place where we end up with something that we know is divisible by 7. Okay, so first of all, let's multiply out those brackets. So that's 3k plus 3 minus 1 plus 3. This is 2 to the power of 3k minus 1 plus a 3, and that plus 3 is still there. What I'm going to do is I'm going to take this piece here, and see I'm angling towards getting this thing here, so that's why I'm going to take that separately. And I'm going to use my laws for indices to separate this into that times that. Okay. And now this 2 to the power of 3, this is equal to 8, right? Times 2 to the power of 3k minus 1, and that plus 3 is still there. And this 8 could be written as 7 plus 1 times 2 to the power of 3k minus 1 plus 3. And then this is equal to 7 times 2 to the power of 3k minus 1. And then plus 1 times 2 to the power of 3, which is this one here, plus 3. So now we have this original expression is now written as with two different parts, okay? Now this first part here, this is divisible by 7. Why? Because it's 7 multiplied by something, so it's obviously divisible by 7. And this second part here, this is divisible by 7 because of the induction hypothesis, because it's just the same thing as what was written in the induction hypothesis. And so we're done. We've proved this by induction. Why have we proved by induction? Because we've done the first step here. We've shown it works for a base case. When n is equal to 1, we get something that's divisible by 7. Then we assume for k. So we assume that it's true. So we make the assumption that this piece here is true. And then we have a look at this here, and we show that, yes, this is also divisible by 7, because it ends up being this thing here, which is divisible by 7. But it's divisible by 7 if the previous one. So if this one is true, then this one is true. That's what we've proved. That's how proof by induction works. So as soon as you get to there, then you can put a little full stop and you're done. Okay, now for part B, we're talking about an arithmetic sequence. So I'm just going to stop immediately and then just go in here into the notes and find out the part of the tables which talks about an arithmetic sequence. Here it is here. So let me just take that across. So here it is here. Now just to remind you about an arithmetic sequence, an arithmetic sequence is you have a starting number which we call A, and you have a common difference D, and then you add the d onto the a to get the second number in the sequence, and then you keep adding this d on to get the subsequent numbers in the sequence. So if we had a is equal to 2 and d is equal to 3, then the first number in the sequence would be 2, and then we would add the 3 onto the 2 to get a 5, and then add 3 onto the 5 to get an 8, and keep on going like this, okay? And what we would say then is that this is the first number, this is the second number, this is the third number, the fourth number, the fifth number, and so on. What they do is they don't want to just call it, just use a number. What they say is term 1, term 2, term 3, term 4, term 5, okay? And then we can think about term n. So we have a formula, instead of having to jump along the sequence like this, we could just jump up to any point in the sequence with the formula Tn is equal to a plus n minus 1 times d. And then the second one here, which I'm not going to prove, is just, well, if we want to take the sum of numbers in the sequence, then we have this, the sum of the sequence is called a series. So if we want to take the series, is n minus 1 times d, like that. So that's what those two formulas mean there, okay? So we're told now that p plus 7, p plus 14, p plus 21 is an arithmetic sequence. And it wants us to find the Tn. So we want to use this formula here to find Tn, like so. Now in order to do that, we need an A and we need a D. Well, A is just the first number in the sequence, so that's P. And then the D is just a gap between numbers. So we can see that that's 7. And that's it. So Tn is equal to P plus n minus 1 times 7. And it says find the smallest value for P for which 2021 is a term in the sequence. So if we go back, A was equal to P and D was equal to 7, and then you've got the number 2021, right? So we're sort of like starting somewhere and jumping forward 7 and jumping forward 7 and jumping forward 7 and so on. And it might happen that we land here on that number on 20, or we could also sort of jump over it, right? So what we want to do is find the smallest starting point so that we land exactly on 2021. Now what happens to us a lot of the time when we're doing maths and we're using these formulas and stuff like this is that we get locked into the idea that there's a formula to solve everything. But sometimes you want to find the magic formula that will do it, but other times you just sort of want to use your sort of common sense. And a way to think about this thing here is just to take this 2021 and then divide it by 7, okay? We'll have a look at why this is true now in a second. So this goes in 2 times. 7 goes into 22 times, remainder 6. Then 7 goes in there 8 times, remainder 6. And then this goes in 8 times, remainder 5. So what we see then is that 2021 is equal to, well, 7 times 288 plus 5, okay? And you see, the thing is that this fits right into our formula, right? That if we were to, so what was our formula from the previous page? So let me just take that over. If we take the P to be 5, and then we were going to do this n minus 1 was, you ended up being 288 times the 7. So if we took that would, how do we get 288? That would be like on the 289th term in the sequence. Then, and if we had started at 5, so if this starting point is 5 and we jump forward 7 and we jump forward 7, after doing this jump forward 288 times, then we land exactly on 2021, So like where you can go wrong with this type of question is you can kind of think, oh, you might like take a formula and apply the wrong formula. So an awful lot of time when you do questions, you also have to use your common sense and stuff. Okay, so the marking scheme then for question 4 part A. So there's a high partial credit of 12, marks out of 15 for this year. And what they say is some valid steps basically in the last part of the problem. So you get your you need to get your assumption hypothesis and use it in some valid way in the final part of so maybe subbing it in or something like that. And then in part B, there's no high partial credit in part B. And then in part B2, there's a high partial credit. Basically, if you had found that 289, for example, you get the high partial credit. So as I say, it's good always to know what the threshold for high partial, because if you don't get a question correct, it would be, it's best to get, in that case, to get a high partial credit. So knowing what the threshold for that high partial credit is important. Okay, so now for question 5, part A, and we're told that the derivative of this function can be written in this special form. Okay, so it can be written in this special form, and then the question is like, what is that special form? So first of all, this is a cubic, and let me just write it out. So f of x is equal to 2x cubed. Now I don't need to do this, but like I find just like writing out the question again gives you an opportunity to look at it like really under the microscope to see what's going on. And you know, we're going to have to get the derivative, so I'll differentiate this. So that's going to be 6x squared plus 12x minus 12. And this is a quadratic, and they want us to write the quadratic in this form where it's like ax plus b all squared plus c. Okay, so how to do this? First things first is, you see this a in front. What I'm going to do is I'm going to divide this 6 outside brackets. So 6x squared plus 12x, sorry, plus 2x minus 2. Okay, that's us gotten off to a start. So now we have to take this x squared plus 2x minus 2, and we have to do this step of completing the square. And how I do this is I look at x squared plus 2x, you see, and I ask myself what squared, right, would give me this x squared and this 2x. Okay, well, it's always going to be the x. You see, that's what we get when we divide that number out in the first place, right? So we leave ourselves with an x squared. And then we take that number 2, you see, and we halve it, so plus 1. Because if we take x plus 1 all squared, it's going to be like x squared plus 2x plus 1, okay? So what we realize from that is if I take like this 1 over to the other side, you see I've got x plus 1 all squared minus 1 is equal to x squared plus 2x, okay? So this rough work piece here will really help you in this question. So what I'm going to do is I'm going to substitute this thing for x squared plus 2x, you see, and that's going to be equal to 6 times, and then big bracket, and then inside x plus 1 all squared minus 1 minus 2. And now I put those two together, I get 6 times x plus 1 all squared minus 3, and try not to lose track of brackets. And then this will be 6 times x plus 1 all squared minus 18. And we're done. So this would be my A here, this would be my B, and this is my C. So A is equal to 6, B is equal to 1, and C is equal to minus 18. So now in part 2, we're told that g of x is equal to 36x plus 5. And we want to find the range of values for x for which f prime of x is greater than g prime of x. Okay, so what we're going to need is we're going to need, you know, if we want to work on like f prime of x is greater than g prime of x, we're going to need what these things are. So from the previous part, f prime of x was equal to, so f prime of x was equal to 6x squared plus 12x minus 12. And we have that g prime of x from here. If we just differentiate this bit here, we get that to be 36. So now what we're going to do is we're going to say f prime of x is greater than g prime of x. That means that 6x squared plus 12x minus 12 is greater than 36. And we bring the 36 over, we've got that 6x squared plus 12x minus 48 is greater than 0. And you know what? I'm going to divide across by the 6, so that's x squared plus 2x minus 8 is greater than 0. Okay, so this question is actually turning into this question here, which is to solve a quadratic inequality. Now notice I could divide across by that 6 because it was a plus number and I didn't change the direction of the inequality. Okay, so how do I solve a quadratic inequality? Well, there are 3 steps. Step 1, you change it into an equation, a quadratic equation. Step 2 is you sort of solve it and plot it. And step 3 is you just look at it and then you make your judgment, okay? So if I take x squared plus 2x minus 8 is equal to 0, I'm going to break that into multiplying two brackets together. Okay, x and x, two numbers that multiply to give minus 8 and add to give plus 2. That's going to be 4 and 2 and minus and plus. And that's going to be x minus 2 is equal to 0, x is equal to 2, and x plus 4, x is equal to minus 4. Okay, so these are the two roots of this quadratic equation. And I go ahead and plot it. Now this is a quadratic equation with a plus number in front of the x squared here. And it has roots 2 and minus 4. So let me do this again, sorry. So this is minus 4 and 2. And then it's a U-shaped like that, okay? And the question was, originally, so we turned it into a quadratic equation. We turned it into a quadratic equation, but originally it was this a quadratic inequality. And the question is, where is this quadratic greater than 0? Well, it's greater than 0 when it's above the x-axis, okay? And that's on these sort of tails here, right? So on this tail here and this tail here, it's greater than 0. Now, what part of the x-axis does that correspond to? Well, this piece and this piece. And how can we write that in a mathsy way? Well, this piece could be written as x is less than minus 4, and this piece could be written as x is greater than 2. Now, it's strictly less than and strictly greater than because that's the way it was written there. And this x less than minus 4 piece can be written as minus 4 is greater than x is greater than 2. So that's how we would write it down. So that is the range of values for which f prime of x is greater than g prime of x. Okay, so now question 5 part B, and what we're looking for is this value of k over here, okay? Now, we get the value of k from the tangent line to the curve, okay? So this tangent line, it's going to be a line like y is equal to mx plus c, okay? And the c will be the y-intercept. That'll be where it cuts the axis, and that will give us that value there, that value of k just there, okay? So what this question really is about is it's about get the tangent line to a curve, okay? And you know it's very easy, like you know when you're doing this, to forget what the point of it is. But if you have a function f of x, okay, or in our case we have a function h of x, so this is our curve h of x like this. Well, what does h prime of x give you? H prime of x gives you slopes, the slopes of tangent lines. So if we were like, you know, like here, at this value, particular value of x here, we'll call it like x1 or something like that, then we can get the slope of the tangent line to the curve there using h prime and then subbing in that value of x there. Maybe that value of x is 10 or something, and then subbing it in. So that would give us like the m, the slope of that tangent line, okay? So what we're going to do is we are going to use calculus to get the m of this one here. But we're also going to need, you know, if we're going to get the equation of a line, we have to use this formula, y minus y1 is equal to m times x minus x1. So we have to sub in m, but we also have to sub in x1, y1 into the same formula. Okay, so we're going to need that point out there. So how are we going to get that point? Well, let's get that one first. So h of x is equal to 2 sine 2x. And the x value is equal to pi over 6. So then we'll go up to the function. So we have to sub in pi over 6 into that function. So that's 2 times sine of 2 pi over 6, which is 2 times sine of pi over 3. Okay, and then sine of pi over 3, we can put that into, we can look in the formula book for that one, because it's one of the, pi over 3 is 60 degrees, so sine of 60 degrees is root 3 over 2, or you can put it into your calculator as well. So that tells us that it's equal to 2 times root 3 over 2, and then that's root 3, okay? So this point here is, that point there is pi over 6 for the x and root 3 for the y, okay? And now h prime of x differentiated. So we have, the 2 just stays there, and then sine, when you differentiate sine, you get cos. But then we've got 2x inside, so we have to use the chain rule, and we differentiate 2x, we get 2, and that comes outside, so it's 2 times 2, so it's 4 times cos 2x, okay? So differentiate 2 sine 2x, you get 4 cos 2x. And then we do h prime of pi over 6, so that's 4 cos of 2 times pi over 6, and then that's 4 cos of, pi over 3, and then using that same table there, cos of pi over 3 is a half, okay? So that's going to be 4 times a half, which is going to be equal to 2. So we have a line, m is equal to 2, and it has this point on it. So now y minus y1 is y minus root 3 is equal to m, which was 2, times x minus pi over 6. Now it might look a little bit sort of ugly, but what we need is get the y on its own on one side. So that would be y is equal to 2x, multiplying that out, minus pi over 3. So we multiply that 2 by the pi over 6, we'll get minus pi over, and then plus a root 3. And you know what I'm going to do? I'm just going to swap those two around, write the root 3 first, plus root 3, and then the minus pi over 3. And now the number in front of, so this formula y is equal to mx plus c. So the number in front of m, that's the slope, which we knew. But then this one here is c. Everything else is then c, which is the y-intercept. So k is equal to root 3 minus pi over 3. Okay, so now looking at the marking scheme for question 5. In part A, I, there's a high partial credit of 8. And basically there, if we got 2 of A, B, and C correct, then we would get the mark. So, for example, getting the 6, first of all, for A was just dividing out that one there. And then just realizing that this x squared plus 2x came from x plus 1 squared. That would be enough to, so if you messed up the end of it, you're still going to get 8 marks out of 10. In A part 2, there's a high partial credit of 8. And if we got the roots of a quadratic found, so if we found this minus 4 and 2, then that would be enough for a high partial credit. And then in part 3, so there's a high partial credit of 8. And well, they say there's like 4 parts of this question. So we have to differentiate this thing. We have to find the slope. We have to find the y value at that point. So we had to differentiate, find the slope, and then find the y value. So if we'd gotten to this point here, where we can sub these into the equation of a line to get the equation of the tangent line, then we get the high partial credit. Question 6. This one's a little bit weird because this graph that we're given here, it's a quadratic, and but it's h prime of x, right? So normally we would be given some function, then we would have to find h prime of x, but we're given the graph of it. So it might sort of like be a little bit confusing. But anyway, the first part of the question is to show that h prime of x is equal to show that this graph here could be written down with this expression here. And what we notice about this graph is that in general, you can't read points off graphs. When they go through the axes, it's clear, okay? So this is clear that there's a point minus 1 for x, 0 for y, 3 for x, 0 for y, and 0 for x, and 6 for y, okay? So basically, if this here was the correct formula, then if we were to sub in these points here, we would get equality, okay? So first of all, h prime of minus 1 is equal to minus 2 times minus 1 squared plus 4 times minus 1 plus 6, which is minus 2 minus 4 plus 6, which is equal to 0. So this point here, that fits to that equation, okay? Now the next one, let's take h prime. We'll do this. Sorry, this point over here now. H prime of 3 is equal to minus 2 times 3 squared plus 4 times 3 plus 6 is equal to minus 2 times 9 plus 12 plus 6. And minus 2 times 9 is minus 18 plus 18 for 12 and 6, and that's a 0. So that one also fits. So this second point here fits. So now let's check this one here. and that's going to be h prime of 0, which is, okay, minus 2 times 0 squared plus 4 times 0 plus 6 is equal to 6. So that one also fits, okay? So that's enough to show that this h prime of x can be written as this thing here, okay? So this graph here can be written as this thing here. Then it says use h prime of x to find the maximum positive value of the slope of the tangent to h of x, okay? So we're going to be, when we do this question here, we're going to need this h prime of x formula and the graph from the previous page. So let me just copy this all over. Now, so we have some function h of x, and we don't know what that is yet. And then h of x has got derivatives h prime of x, and this is a plot of those derivatives, okay? Now remember, the derivative means the slope, and then the maximum slope will be the maximum of this graph here. So if we look at this graph here and we look for its maximum, then we'll have what the maximum slope of h prime of x is. It's kind of a standard question, but the way they've given to you is kind of a little bit confusing because they're asking all their questions about h prime of x. But what we do is we just take h prime of x and we just treat it like a function, any function that we're trying to get the maximum of, okay? So how do we do that? If we want to get the maximum of a function, we just we differentiate it and then we set it equal to 0, okay? So differentiating h prime of x will give us h double prime of x. That'll be minus 4x plus 4. And then we set that equal to 0. And then we have that minus 4x is equal to minus 4, so x is equal to 1, okay? So what we're saying is that the maximum of this function is here at 1. That makes sense because 1 is the same distance away from minus 1 as it is from 3. So the maximum for a quadratic equation is always halfway in between the roots, okay? So although it's not enough to say that you have to use calculus to get the maximum, but we can check it with that there. So the maximum occurs at x is equal to 1, but in order to find out what the maximum is, then we have to sub in we have to sub in 1 into h prime. So minus 2 times 1 squared plus 4 times 1 plus 6. So that's going to be minus 2 and then plus 4 plus 6, which will be minus 2 plus 10, which will be equal to 8. The maximum value for h prime of x is equal to 8. Now, it might be kind of confusing, like, you know, because it's a question where we have this h prime of x, it might be kind of confusing. But like, when you're doing these questions, like, you should be expecting that you have to differentiate, like set it equal to 0. And so if you just try to do something like that, you know, oftentimes maybe you don't entirely know that what you're doing is going to lead to the right answer. But, you know, there are always sensible steps that you can take in these questions. They always ask the questions about the same sort of stuff. So, you know, taking these steps would be a sensible thing to do. And then what would happen is that after you make some sensible steps, you just find that you're suddenly, you know, oh, I've got the answer. I've stumbled on the right answer. And then we're told that the graph of h of x passes through the point 0, minus 2, and then we have to find the equation of h of x. So now we're looking for h of x. Okay, what did we have already? Well, we had that h prime of x was equal to minus 2x squared plus 4x plus 6. Now, if we have h prime of x, how do we get h of x from that? Well, h of x is we have to integrate. So if we have, you know, h of x, we get to h prime of x by differentiating, but we get back the way by integrating, okay? So we're going to integrate, and we don't have any limits for the integral, so this is an indefinite integral, minus 2x squared plus 4x plus 6. Okay, so how do we integrate? So let's just remind ourselves about how to do that. So we go over here to the, to the section on integration, which is somewhere here. And we're going to use this rule here, okay? So when we're integrating x to some power, we increase the power by 1, and then we divide the whole thing by whatever we got, okay? So for here, it's going to be equal to minus 2, because it's multiplying, so it doesn't do anything. X squared goes to x cubed over 3, plus 4 times x squared over 2, plus 6 times x, and then a plus c. Okay, so h of x is equal to that. Now, this plus c, that we don't have the answer yet, okay? But we're told it goes through the point 0 to minus 2. So we can sub that point in. So h of 0, well, we know that that's going to be minus 2 is equal to minus 2 times 0 cubed over 3 plus 4 times 0 squared over 2 plus 6 times 0 plus c. So everything goes except for the c, which ends up being equal to minus 2. So that tells us in the end that h of x is then equal to minus 2x cubed over 3. They cancel, plus 2x squared plus 6x minus 2. Okay, so for question 6a, there's a high partial credit of 8, and we get that high partial credit. In this case, there's a number of different ways that we can get the high partial credit, but for example, one of the ways was if we subbed in 2 of the points. So we verified that 2 of the points fit into the two points from the graph fit into the function for h prime of x. That would be a way to get that. The reason why I concentrate on the high partial credit is because if you're not going to get full marks, if you're going to fall short of full marks in a question, it's good to know where the high partial credit is, right? Because it's often, in some cases, it doesn't take very much to get the high partial credit. You just have to start off in the correct way and use the correct method. And then in part B, there's a high partial credit of 7, and you get that if you find that the maximum occurs when x is equal to 1. So if you get the derivative of h prime of x, if you get h double prime of x equal to this, and you find that you get the maximum of x equal to 1, then you get the high partial credit. And then in part B, there's a high partial credit of 8. And basically, if you didn't get the c was equal to minus 2, but if you got down to this line here, and then you did some relevant substitution, so maybe you subbed in the minus 2 in place of x, but you didn't put in the 0, you didn't do that fully correctly. So if you fall short of this line here, you get the high partial credit. Okay, so thank you for watching my video on maths, higher level maths, paper 1, section A from 2021. I'm going to follow this video up with a video on section B, and there'll be other videos on other years. Okay, thank you.